The island does not appear on most maps. It has no harbor, no civilians, no cover, only wind instruments bolted to coral and men waiting for storms that decide wars. Here, thousands of miles from Washington and Tokyo, the fate of entire fleets begins with a single pressure reading. Central Pacific Ocean, Forward U.S. Weather Station, early 1940s, wet season. This story follows the most isolated American weather teams of the Pacific War, small U.S. Army Air Forces and Navy detachments, inserted onto hostile forgotten islands to read the sky before the enemy could, shaping invasions, air raids, and carrier strikes, long before the first shot was fired. The island sits low against the horizon, a thin smear of coral and scrub, barely rising above the surrounding Pacific. From the air it looks uninhabitable, a place the ocean has not yet decided to erase. There are no ports, no paved runways, no permanent structures, only a narrow cleared strip, a scattering of canvas tents, and a cluster of fragile instruments, mounted on steel poles driven into limestone that cracks under repeated blows. Wind moves across the atoll without obstruction, carrying salt that coats everything it touches. The air tastes metallic. The heat presses down with a steady, suffocating weight. This is not a combat outpost by design. No artillery is emplaced. No fighters stand ready on revetments. Yet the men stationed here understand that what they observe will shape battles hundreds of miles away. Their mission is simple in wording and merciless in execution. Measure the atmosphere before it becomes violence. Pressure, wind shear, cloud ceiling, swell direction. Data collected by hand, every hour, day and night, regardless of weather or threat. The station operates with minimal redundancy. A barometer cracks during unloading and is repaired with scavenged parts. Radios function intermittently, vulnerable to humidity and corrosion. When transmissions fail, runners are sent to the antenna mast to realign cables while lightning advances across the open sea. There is no rotation schedule. Relief depends on shipping lanes that may or may not open for weeks. The men learn to ration not just food and water, but attention and fatigue. Above them, the sky is never neutral. Morning often arrives with deceptive clarity. High cirrus, stretching thin like pulled cotton, sunlight refracted through moisture, invisible to the eye. By midday, the Pacific begins to announce its intentions. Pressure drops subtly at first, measurable only to those who know the instruments well enough to sense deviation before confirmation. Trade winds shift a few degrees. Swell patterns change, lengthening, stacking energy toward unseen fronts, forming beyond the horizon. These readings will not stay here. They will be encoded, transmitted, relayed through relay stations and command posts, eventually arriving on plotting tables aboard carriers and at headquarters carved into volcanic rock. Admirals will adjust launch times, bomber groups will alter altitude profiles. Amphibious landings will wait, or go forward, based on numbers written by men standing barefoot on coral in the rain. The enemy is rarely visible, but always present. Japanese reconnaissance aircraft occasionally pass high overhead, their engines a distant vibration more felt than heard. Submarines have been reported offshore. At night, blackout discipline is absolute. Even cigarette embers are forbidden. The instruments remain exposed, outlined faintly by starlight and phosphorescence, breaking on the reef. There is no glory attached to the work. No immediate confirmation of success, only the knowledge that failure, one missed pressure trend, one delayed report, can send aircraft into walls of cloud, scatter invasion fleets, or expose task forces to typhoons that do not discriminate between flags. Here the war begins hours before combat. Here victory is measured in advance. The decision to place American weather teams on the most remote islands of the Pacific does not emerge from curiosity or scientific ambition. It is born from catastrophe. In the opening phases of the war, U.S. naval and air operations repeatedly collide with an enemy that cannot be seen on radar or plotted by reconnaissance photography. Storm systems, scatter formations, low cloud ceilings force bombers to abort. Sudden wind shifts turn routine landings into fatal miscalculations. Again and again, aircraft are lost without enemy contact. Fleets arrive late. Assaults are postponed or launched blind. The Pacific is not a passive environment. It is a dynamic system of moving pressure masses thousands of miles wide, governed by trade winds, convergence zones, and seasonal oscillations that can transform calm seas into chaos within hours. Weather patterns here do not behave like those over continental landmasses. Forecasts generated from distant stations are unreliable, delayed, and dangerously incomplete. To fight across this ocean without controlling its atmosphere is to surrender initiative before combat begins. Japanese forces understand this early. Their meteorological services, refined through decades of maritime operations, emphasize forward observation. Island chains are used not only as airfields and defensive outposts, but as atmospheric sentinels. Data gathered in the Western Pacific flows eastward, shaping operational timing. American planners recognize the imbalance. If invasions are to succeed, if carrier task forces are to strike with precision rather than chance, the sky itself must be contested. Thus begins the quiet expansion of U.S. Army, Air Forces, and Navy weather detachments, small, specialized units trained in meteorology, radio operation, and survival. Their equipment is basic but precise: mercurial barometers, anemometers, ceilometers, radios, and balloons filled by hand and released into unstable skies. Their training emphasizes discipline under isolation. Many are scientists by background, others technicians taught to read subtle atmospheric signals that cannot be taught quickly. Deployment follows the advancing front, as Marines and Army units seize islands across the Central Pacific. Weather teams arrive soon after, sometimes within days, sometimes under fire. They establish stations wherever possible: coral atolls barely above sea level, volcanic ridges exposed to constant wind, jungle clearings hacked from terrain that immediately begins reclaiming itself. Each station extends American awareness farther west, shortening the distance between observation and decision. The work is continuous. Observations are logged every hour, regardless of fatigue or conditions. Balloon launches occur in darkness, rain, and gale force winds. Radios are kept alive with improvised repairs. Reports are encoded and transmitted on fixed schedules. Missed transmissions trigger concern at higher command, because silence itself may indicate approaching disaster. What makes these teams indispensable is not the drama of their environment, but the compression of time. A pressure drop detected here may translate into a storm over a carrier group 12 hours later. A wind shift observed on a forgotten atoll can determine whether bombers reach their target with fuel to spare or ditch at sea. In this war, information that arrives too late is indistinguishable from ignorance. As the American advance accelerates, these outposts become part of a growing atmospheric network stretching across thousands of miles of ocean. Each station is small, each is vulnerable, yet together they allow U.S. forces to plan with confidence in a domain that had once been ruled by chance. The war for the Pacific will still be fought with ships, aircraft, and men, but it will now be preceded, quietly, relentlessly, by a war for the sky. The first sign does not arrive as violence. It comes as deviation, a fractional pressure drop recorded just after midnight, small enough to be dismissed by anyone unfamiliar with the station's baseline, yet persistent enough to demand attention. The barometer needle hesitates, then settles lower than it has in days. Wind speed increases by increments rather than gusts, a steady acceleration that suggests organization rather than randomness. High cloud layers thicken, their movement no longer aligned with surface flow. By dawn, The pattern is unmistakable. A developing system is advancing from the west, fed by warm ocean currents and guided by upper-level winds that compress energy forward. The sky takes on a dulled brightness, sunlight filtered through expanding cloud decks that erase shadows and flatten the horizon. Radiosun balloons are launched before sunrise, their ascent tracked carefully until signal loss. Each data point confirms the same conclusion. Instability is building faster than predicted by rear area forecasts. The report is encoded and transmitted on schedule, then resent for redundancy. From this island, the information begins its journey eastward, passed from relay station to relay station, moving faster than the storm itself. Hours later, it will reach carrier task forces refueling at sea, bomber groups preparing for long-range missions, amphibious planners watching narrow windows close or widen based on variables beyond human control. By mid-morning, the first physical contact arrives from the enemy. A distant engine note appears above the wind, high and thin. The aircraft remains above cloud cover, invisible, except for the faint metallic vibration carried downward. No attack follows. The reconnaissance pass is brief, clinical. The men at the station understand its purpose. The enemy is reading the same sky, searching for advantage in the same shifting atmosphere. Weather observations continue uninterrupted. Instruments are checked, recalibrated, shielded where possible. Rain begins lightly, then with increasing density, reducing visibility to a uniform gray. Antenna cables are secured. Transmissions are shortened, but maintained. Lightning advances in slow pulses across the open sea, each strike illuminating cloud towers that now dominate the western horizon. By afternoon, confirmation arrives through command channels. Carrier operations scheduled for the following day are adjusted. Bomber launch windows shift forward by hours. A planned surface movement is delayed to avoid heavy seas forming along the system's projected path. Decisions affecting thousands of men and millions of tons of material are altered without fanfare, based on numbers written in a logbook on a forgotten island. As evening approaches, conditions deteriorate rapidly. Wind-driven rain strips the island of color. Instruments vibrate under sustained gusts. The pressure continues to fall. There is no shelter adequate for the coming hours, only preparation. Observations are maintained manually as automated systems fail. Fatigue becomes a secondary concern. Accuracy does not. The storm will strike fleets and air groups long after it leaves this place behind. Here its arrival has already served its purpose. The pressure reaches its lowest point shortly after midnight. By then, the island has ceased to function as terrain and become instead a surface for wind to cross. Rain no longer falls in drops, but moves horizontally, driven by sustained gusts that bend instrument masts and tear at canvas with a steady structural violence. The sea beyond the reef is no longer distinguishable from the sky. Both have merged into a single moving mass of darkened water and cloud. Operations continue by necessity, rather than comfort. Barometers are read by shielded lantern light. Anemometer cups spin beyond calibrated limits, forcing manual estimates based on vibration and sound. Radios fail intermittently as moisture intrudes, where sealing compounds have long since broken down. Each transmission is attempted repeatedly until confirmation is received or power drops too low to continue. Silence is unacceptable. The men understand what is at stake with unusual clarity. Somewhere beyond the horizon, American carriers are riding heavy seas, their flight decks unusable for hours at a time. Aircraft secured on deck strain against tie-downs. Below, engineering crews fight flooding and maintain propulsion in conditions that allow no margin for error. Bomber formations waiting on island airfields inland depend on accurate timing to avoid launching into airspace that will scatter them beyond recovery. At the station, exhaustion builds methodically. Hands remain swollen from salt exposure. Eyes burn from constant wind and rain. There is no opportunity for full rest. Observations are taken, logged, transmitted, and then repeated. When instruments fail entirely, estimates are derived from experience, cross-checked against partial readings and visual cues in cloud movement and sea state. This is no longer meteorology by procedure alone, but by judgment refined under pressure. Near dawn, a structural failure occurs. One of the primary antenna supports gives way, collapsing into the scrub and severing a transmission line. Repair teams move immediately, exposed to the storm without cover. The work is slow, precise, and dangerous. Each minute without transmission increases uncertainty at command posts, now shaping operations based on incomplete information. The line is restored, power stabilizes, reports resume. By mid-morning, the pressure begins to rise. The wind shifts direction subtly, then decisively. The storm's center moves past the island, carrying its worst force eastward toward open ocean. Here conditions degrade only briefly before beginning their long recession. The sky lightens unevenly. Cloud layers break and reform. The sea remains violent, but its rhythm changes. Later that day, confirmation filters back through command channels. Air operations delayed by the storm resume. Under clearer conditions, carrier groups avoid the worst seas by margins measured in hours. Aircraft return safely that would otherwise have been lost to fuel exhaustion or deck accidents. There is no message of praise. There is only the absence of disaster. When the station finally stands down from continuous observation, the island looks scoured. Equipment is damaged. Supplies are reduced. The men are depleted. Yet the mission holds. The storm has passed. The line has not broken. When the sea finally settles and regular transmission schedules resume, the island returns to its familiar state of obscurity. No headlines mark what occurred here. No unit citations are issued. Supply ships arrive late and leave quickly, unloading replacement instruments and taking away damaged equipment without ceremony. The war moves on, westward, faster than memory, yet the consequences of what happened ripple outward through operational reports and planning documents. Carrier logs record avoided losses attributed to weather timing. Air Group after action summaries note missions flown under unexpectedly favorable conditions following last-minute adjustments. Amphibious operations proceed with confidence that would have been unthinkable earlier in the campaign. The sky, once an unpredictable adversary, becomes a managed variable across the Pacific. Similar stations multiply. Some are larger, better supplied. Others are even more isolated than this one, positioned on volcanic ridges, wind-scoured reefs, or jungle-covered rises that challenge endurance as much as enemy action ever could. Together, they form an invisible lattice of observation, stretching from rear areas to the forward edge of combat. Each node is fragile, the network is resilient. American commanders come to trust these reports implicitly. Launch times are set with atmospheric margins calculated in advance. Fuel loads are adjusted based on predicted headwinds. Strike altitudes are chosen to exploit cloud layers rather than be trapped by them. Enemy movements are anticipated not only through intelligence, but through the behavior of pressure systems that dictate when and where aircraft can operate effectively. The men who serve at these stations rotate quietly when possible. Some do not. Illness, exposure, and isolation take their toll. Others remain through multiple seasons, watching the same patterns repeat with subtle variation, refining their understanding until forecasting becomes as much intuition as science. Their work does not end with victory in a single battle. It continues until the war itself begins to close. In the final years of the Pacific Campaign, American operational tempo accelerates dramatically. Carrier task forces strike with increasing precision. Long-range bombing becomes routine rather than exceptional. Amphibious assaults proceed on tightly controlled schedules that leave little to chance. The weather still matters, but it is no longer unknowable. After the war, the stations are dismantled, instruments are packed away, logs are archived, the islands return to silence, their brief role in global conflict unmarked. What remains is institutional memory. The United States emerges from the Pacific War with a transformed understanding of environmental intelligence, embedding meteorology permanently into military planning at every level. The victories remembered are those fought with steel and fire, but far from the front lines, on forgotten strips of coral and rock. The war was also won by men who measured the wind and sent it eastward in time.